To select all that are equivalent, what we want to do is start reducing this radical and check it each step of the way. So whenever we have a negative inside the square root, we take out our I. So we have 3i square root of 40. So before we go on, we're going to go over here, we're going to check, and we actually see that, so we're going to shade that in. Shade it in just a little bit so that we know it's selected. So 40 is not a perfect square, so what we're going to do is we're going to make a factor tree for it. So 40, you can start off wherever you want. You can start off with 4 and 10, 2 and 20, doesn't matter, because we're going to keep going with our factor tree. So 4 is 2 and 2, 10 is 2 and 5. Once we get all the way down to the bottom of our factor tree, which means nothing else will go into any of these numbers, we look for pairs. So we have a pair of 2's right here, but we're also left with this 2 and this 5 over here that are left by themselves. So what we're going to do is we're going to take out 1, 2 from this pair, and it's going to be multiplied with that 3 that we already took out. This 2 and this 5 stay inside, they get multiplied back together. So we check our little table again. I don't see that anywhere. So 2 times 3 is 6. I square root of 10. Check our table. And it's this one right here. Be careful of stuff like this where the I is on the outside of, or the other side of the square root. It's actually inside the square root and we don't want that. So just be careful of that. So here's another simplification one. So same basic idea. We have our negatives, we're going to take out our I. It's going to be our first step. We take out the I, it makes it inside positive since I is the square root of negative 1. 60 is not a perfect square, so we're going to make a factor tree. Again, start wherever you want. First thing that pops in my mind is 6 and 10. 6 would give us 3 times 2, and 10 would give us 2 times 5. So again, all the way at the bottom, nothing goes into these because they're prime. So I see a pair of 2's, a lonesome 3, and a lonesome 5. This stuff up here we don't care about anymore. So we're going to have the 2 come out, gets multiplied with the 6 that's already outside. And then the 3 and the 5 stay together, get multiplied on the inside. So then we just want to reduce this. 2 times 6 is 12. I square root 3 times 5 is 15. And there's our answer. So 12i square root of 15. So now we have some multiplication. We know it's multiplication because between these there's nothing. So we have 7 minus 9i times negative 11 minus 6i. So under this we're going to distribute everything from the first set of parentheses, so the 7 to both the numbers, and the negative 9i to both numbers. So everything in the first set, everything in the second set. So 7 times negative 11 plus 7 times negative 6i. Keep going, so minus 9i times negative 11 minus 9i times negative 6. The pluses and minuses come from whatever sign that number is. Positive is plus, negative is minus. So we're going to go ahead and reduce all of these. Just be careful as you're going along. Your I's stay there. Remember, negatives and negatives make positives, so we can just write that as plus. And then so negative 9 times negative 6 is positive 54. I times I is I squared. Okay, we can't forget that. We also have to remember that I squared equals negative 1. So what we're going to do is, before we start combining like terms, we're going to replace that I squared with negative 1. So we get negative 77 minus 42i plus 99i plus 54, and then I squared we just replace completely with negative 1. So 54 times negative 1. So what I did next was just multiply the 54 by negative 1 and it became minus 54. So we can start combining our like terms. We want standard form, which is a plus bi, which means the number comes first. So we're going to combine negative 77 with negative 54, which gives us negative 131. And then we're going to combine this negative 41i with this 99i, which will give us a positive, so plus 57i. And there's our answer for us. So that's multiplication. So again, this one wants standard form, but now this time it's subtraction. So we're not going to be distributing everything in the first set to everything in the second set. We don't do that with subtraction. That does not make any sense. What we do want though, is we want this as an addition problem instead of a subtraction problem. So what we're going to do is we're going to take this negative sign and we're going to distribute it in. Remember, it's not the first set of parentheses, we're just flipping the signs of the second so that we get it as no parentheses. We can drop the parentheses at this point. So once we do that, so 8 becomes negative 8, minus 5i becomes plus 5i. Combine like terms. 4 minus 8 is negative 4. Positive 3i plus 5i gives us plus 8i. Now we're done. If it was addition, you would just start combining like terms. Subtraction, we distribute the negative, then combine like terms. So we have Maricela, who did an addition problem. She has her work below, so she messed up somewhere. We want to figure out what her error was and to show the correct answer. Easiest thing to do with these is to actually do the correct work first. By doing the correct work first, we get an idea of what the answer should be, and then we can actually look at hers and see where she messed up. So since this is addition, we can just start combining like terms. So we have that 8 plus 15, which would give us 23. And then we have this 9i minus 6i, which should give us plus 3i. So 23 plus 3i. So we look at Maricela's work. Okay, so she has the problem. She moves stuff around so she could add it. Okay, so she got 23 plus 3i, which is what we did, but then she combined them together. Okay, so that's her error. We can't do that. So to explain her error, we would say something like she combined the 23 and the 3i, but they're not like terms. So that would be her error.